So we have 3 identical 1.5 volt bulbs connected to 2 1.5 volt cells. So when you have cells in series, you add the voltages, you add the EMFs. So the total EMF here would be 3 volts. The switch is not closed to begin with. So initially the current is just going this way. It's bypassing X, it's going through Y. So these two components are in series. So to begin with, these two have identical resistance and they're in series, so voltage splits in the same ratio as resistance. So we will get 1.5 volts here and 1.5 volts there. They'll have the same brightness because they get the same voltage. If they get the same voltage, they get the same current, and that's also the case because, well, it's in series, so whatever current Y gets will be what Z gets. So same voltage, same current, same power. If they have the same power, then they will have the same brightness. So that's the starting scenario. Now, when we close the switch, things change. Now we have X and Y being in parallel. And if X and Y are in parallel, let's say that the resistances are. Now, in reality, when you change the voltage or current through a bulb, its resistance will change. So the resistances will no longer actually all be the same. But either way, the end answer will be the same. So I'm just going to consider that they're all identical resistors, or they all have identical resistance, and that will just make the explanation much easier. So they all have a resistance R. These two are now in parallel, as this circuit is now closed, or switch is now closed. And the total resistance of these two, if we use the parallel equation for adding up resistors, this gives 2 over R, and then RT will be R of 2. So the total resistance of these two is R over 2. Now voltage splits in the same ratio as resistance for resistors in a series. These two are in series with this. So then the ratio of resistance is now R over 2 to R. It's no longer 1 to 1. When it was just Y and Z, they had the same resistance. The split of voltage would be 1 to 1. But now the split of voltage is going to be 1/2 to 1 or 1 to 2 between X, Y, and Z. And so that means that Z is now going to get a greater voltage than it did before. If we were to use these numbers, Z would get 2 volts, and then X and Y would end up getting 1 volt. I'll put that in purple. Again, the resistances might not be exactly R anymore, because if these two components are getting less voltage, they will cool down as the power dissipated decreases, and therefore their resistance will be a little bit lower. But we can ignore that. The end result is the same. If Z gets more voltage, that means it gets more power. If we think about an IV characteristic for a bulb, that looks like this. So as the voltage increases, the current increases, although at an ever decreasing rate, but it still increases. And so if the voltage and current increase, power increases. Z now has more voltage, it therefore gets more power, it is therefore brighter. For Y used to get 1.5 volts, now it's getting 1 volt or less, and so it will now be dimmer. For the same reasoning, less voltage, less current, less power. So our answer will therefore be C.